Well, hi guys. I'm going to pull up a little math funny for you guys before we get started on this lesson. We're starting Unit 6, Part 2, which means we're going to be looking at the back side of your formula chart, which starts with double argument. That's what we're doing today. By Abby.
Dang it, I'm going to be on there.
Yes, that was Abby Chin, one of the BC Calculus kids on the video. Okay, so anyway, we're going to start with a little funny. So here's our funny. This is only funny if you're smart. And if you're not smart, then you're going to have to call up your buddy and say, hey, I don't get this. And they'll tell you to pull out your formula chart. But see, if you're smart, this is funny. But if you have to explain something to somebody, it doesn't make it funny at all. Only other funny I wanted to look at today also was these West Virginia players. I don't think that these two should ever sit next to each other on the bench. But anyway, let's start with a little funny there. Okay, so what we're going to do is take a look at a double argument, which is sine of 2x and cosine of 2x and tangent of 2x. And they have formulas, and what I want you to notice is that the 2x here, 2x is twice as big as x. So these are different angles. So this angle that I'm dealing with, that's called an argument, you can find the sine of this double angle by only using the sine and cosine of half of that angle, basically, and then times 2. So these formulas you need to understand. I'm going to be finding information about an angle without drawing that angle. I'll be drawing an angle that's actually about half of that value. Cosine of 2x is weird. It has 3 different forms, and because cosine squared plus sine squared is 1, you can replace this cosine squared with 1 minus sine squared, and you get the second formula. Or you could replace the sine squared with 1 minus cosine squared, and you get the third formula. So you get 3 choices on what to use for cosine of 2x. And then there's your tangent of 2x formula. So we're going to be looking at that. So let's get started. We are going to go over here in blue. All right, we're going to find the exact value of sine 2x, cosine 2x, and tangent of 2x under the given conditions. So we know the sine of x is 3/4, and we also know that pi over 2 is less than x is less than pi. What does this tell us? This gives us a domain for where to put our angle. And so what's bigger than pi over 2 but less than pi? Well, that's between 90 and 180. So that tells us that we are dealing with quadrant 2. So let's take a look at this. So I know that I'm over here in quadrant 2. So I'm going to draw my triangle over there. Oh, get down there. Anyway, la 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 la. That was not a very good start, but we're going to keep it. We're going to erase this little bitty mistake in there. Yeah, that looks better. Okay. So we're going to label our sides. Now our angle x is right here, bigger than 90 but less than 180. And we can find sine and cosine and tangent from our reference angles. But once you understand, we're going to be finding information about sine, cosine, and tangent, which is twice as big as this. So where would a triangle be that's twice as big as this? Well, it's going to be bigger than pi but less than 2 pi, so it's going to be somewhere in here. Alright, sine of x equals 3/4, so I know my opposite side is a 3, my hypotenuse is a 4, and if we do our Pythagorean theorem, 4 squared minus 3 squared, I'm going to get 16 minus 9, or 7, so this side is the square root of 7, and of course it's negative because I went left. Alright, so let's find the sine of the 2x, this angle, this mystery angle that we don't know about. I can find the sine of 2x by looking at the formula chart. It says that's 2 sine of x times cosine of x. And they were nice enough to give me what the sine of x is. The sine of x is 3/4. Notice I completely replaced sine of x with 3/4. I didn't replace sine of x with sine of 3/4 like some of you guys were doing when we were working on sum of differences last week. And then cosine of x is equal to negative square root of 7 over 4, adjacent over hypotenuse. So if we work this out, we get, you put a 1 underneath that 2, and we're going to multiply straight across. So I'm going to get negative 6 square roots of 7 over 16, which simplifies to negative 3 square roots of 7 over 8. Let's go over here and do the cosine of 2x. And you saw the cosine of 2x had 3 different formulas. I can use any of those 3. I'll do cosine squared x minus sine squared x. I'll just use the first one because I have cosine and sine. I want you to understand that this is the same thing as cosine x all squared minus sine of x all squared. So that means that this is going to be negative square root of 7 over 4 squared minus 3 over 4 squared. Okay, and of course we all know the square of fraction, we square the top and we square the bottom. So this is 7/16 minus 9/16. And so what are we going to get here? We're going to get negative 2/16, which is negative 1/8. Now that should tell us something about where we were here. If we know that the cosine of the double angle is negative, it should tell us where it ended up, that it actually ended up being in quadrant 3. So this must have been just a little bit bigger than 90. At least it was before 135 degrees. Okay, and the last thing we're going to do is find the tangent of 2x. And of course, we could find the tangent of 2x by using the formula, but since I've already done sine and cosine, I'm going to say that the tangent of 2x is the sine of 2x divided by the cosine of 2x. And since cosine of 2x was already a fraction, I'm going to do times the reciprocal. So I'm going to get 3 square roots of 7. And that should be what you also get if you plug it into your formula. So I did sine divided by cosine there. All right, let's keep going here to our next page. All right, the next thing we're going to do is a little general solution and also particular values. And so what I'm going to do is look at this equation, and what I'm going to do is I'm going to figure out how can I manipulate this equation so that it looks like one of our formula chart formulas, or I want to turn it really into a single trig function. I don't want sine and cosine here. So what I can do is if I divide both sides by 2, I get one of our formula chart statements. So dividing by 2, I get 2 sine cosine, which we know that that is the sine of 2x. And so what I've done is I've turned this into something that I can actually solve. I can't solve a trig equation if I have a, oh wait a minute, what did I do wrong here? Oh, I see what I did wrong. Dividing by 2 on the 1, and I did it twice. Okay, do you see what I did here? Let's try that again. I'm sorry, I'm sort of in a hurry because tonight is my youngest daughter's birthday and she's turning 10, and I need to take my time here. I apologize. Let's try that again. If we divide both sides by 2, we get that 2 sine of x cosine of x is equal to 1. So now I know that the sine of 2x is equal to 1. So let's solve this equation. I'm going to arc sine both sides, and I'm going to get the arc sine of 1, which is pi over 2 plus 2 pi n, and also 2x equals pi minus that. Pi minus pi over 2 plus 2 pi n, which ends up being the exact same equation. So there's only one place where sine is equal to 1. So now we're going to divide both sides by 4, and we're going to get pi over 4. Sorry, divide both sides by 2. I don't know what I just said. Anyway, so I'm going to get pi over 4 plus pi n is my solution there. And what I want now is all of the angles between 0 and 2 pi. So my first one is pi over 4. My next one is going to be 5 pi over 4 because I added pi to that. And if I add pi one more time, I'm going to get 9 pi over 4, which is outside of the range. So that's my answer for B. Okay, last thing is simplifying statements that are sine and cosine statements into a double angles. This example says I've got sine of 14x and I want to write it in terms of sine of 7x and cosine of 7x. You can use that double angle formula as long as you're dealing with an angle that's twice as big as the other one. So sine of 14x can be turned into sine of 7x and cosine of 7x with our formula chart. Sine of 14x happens to be twice as big as 7x. So because the sine of 2x is 2 sine of x cosine of x, you can think about your 2x here as 14x. So if 2x is 14x, then 1x is 7x. So that's why we have 2 sine of 7x times cosine of 7x. And write tangent of 26x in terms of tangent of 13x. Well, from the formula chart, we know that the tangent of 2x is equal to 2 tangent x over 1 minus tangent squared of x. Two tangent x over 1 minus tangent squared of x. And x and 2x have that double relationship. So if 2x is 26x, then 1x is 13x. So I'm going to put 13x's here. So the tangent of 26x is 2 tangent of 13x over 1 minus the tangent squared of 13x. So on this last one is where I have to choose between those three forms of cosine of 2x. I want to write cosine of 10x in terms of sine of 5x. So I'm going to have to use my cosine of 2x equals 1 minus 2 sine squared of x. And I have to choose that one because I just have to have a sine here. So that's going to say that the cosine of 10x is equal to 1 minus 2 sine squared of 5x. And there you go. That's all. I will see you guys tomorrow. But wait a minute. Lucas,
Yes.
say hi to everybody.
Hello.
That was Lucas. All right. Deuces.